All right, so looking at number 26, do you see what's going on in 26? Like it's like all of these are like pattern recognition things. Do you see which type of factoring we're going to use for 26? Anybody see or recognize what pattern that would be? Difference of squares. It's a difference of squares. It's something squared minus something else squared. So x squared minus y squared. Or yesterday we were doing, triangle squared minus circle squared. So I got something squared minus something else squared. And we know that factors into x plus y, x minus y. So that's the pattern we have to know. Now we'll apply that pattern to this particular problem. So what would we be squaring to get to 25a to the fourth? 5a squared. We put that in both spots now. So now we know it's 5a squared plus something and 5a squared minus something. Well, what would we square to get a minus 1 squared? A minus 1. So plus a minus 1 and minus. Be careful on the minus. Yeah, either put it in parentheses so it's minus a minus 1, or you could distribute and make it a plus 1. Again, it's this idea of I got something squared, something else squared, so fit the pattern. All right, 27, another sort of pattern type problem. Something squared plus 8 times the something plus 16. That k minus 3 is kind of ugly. In fact, what we can do, like if this was anything other than k minus 3, I feel like this would be an easier problem to solve. So we do this a lot. The further you go in math, the more you do it. We do it a lot in calculus. And that is, look, the k minus 3 is kind of messing me up here. So I'm going to replace k minus 3 with something else that makes my life a little easier. Like, wait, you're allowed to do that? Like, you're allowed to do that as long as you fix it later. So wherever there was a k minus 3, I'm going to put a u. Hopefully when you do that, you're like, oh, that looks a lot easier. I can definitely factor that. Now, having said that, I'm going to pick on somebody and see if they can definitely factor that. But I have faith in Jenna. So, Jenna, what do you think? How does u squared plus 8u plus 16 factor? Okay, she jumped straight to the end, which is fine. U plus 4 squared. Because it's u plus 4 and u plus 4. Multiply to 16, add to 8. Okay, but we're not through with this problem because this started out as a k problem, not a u problem. But I did the u stuff, made my factoring easier. Now I'm going to put k minus 3 back in for u. So k minus 3 plus 4 squared, but then minus 3 plus 4, that becomes k plus 1 squared. Okay, we hadn't done one like that yesterday. Someone in first period, and this is a perfectly okay way to do it. They multiplied, they FOILed this, distributed the 8, collected all the terms, and then factored, and then got k plus 1 squared. So you don't have to use this. Like you could multiply it all out, blow it all up, combine it, put it all back together, and then factor, and you'd still get back to this. So having said that, why don't you try 28? What do you think would be a good substitution for 28? See if we get everybody started on the right track here. What would be a good substitution to make 28 easier? 2 minus m. All right, so I'm going to press pause and see if you can take 28 from there. Not too bad. I guess the main trick, A common mistake on these is to stop right there. Why is that not right? I got to put the stuff back in there. So the use substitution is great. It made my factoring a little bit easier to handle, but I'm not done until I put 2 minus m back in for u, and then we could clean that up a little bit. That would be, let's see, negative 5 minus m, or negative m minus 5. I guess it wouldn't really matter which order you put them in. And again, that's another one where if you wanted to go the long way around and FOIL it out, combine all the like terms, and then factor it, that'd be fine. You'd eventually land at the same spot. There was one other new type of problem that we hadn't seen before, and that's jump down to 40. So 40, 41, 42, we've seen that type before, where you factor by grouping, group the first two, group the second two, greatest common factor. In fact, why don't you try 43? That'll lead us into 44. All right, let's look at 45. Again, you can group the first three, and it just takes time to recognize when you should group the first two, when you should group 2 and 2 versus 3 and 1. And after you've factored a whole bunch, you start to realize, oh, that makes a nice factor, those first three. Same thing on 44. But on the previous ones, there weren't 3 that really went together. It was definitely 2 and 2. So it's just practice and experience that helps you recognize which way to go. Let's see, k plus 7 squared minus g squared. And so that's another one of those difference of squareds. So first one plus the second one, first one minus the second one. K's and G's and 7's, all sorts of weird stuff. All right, do you have further questions? Those are the ones I wanted to work. Any that you want to see? Ella?
47.
37. Oh, we almost made it there. Did you see something we could do first? Or not?
Take out the CD.
I could take out a C plus D.
Oh, sorry. C plus D.
So I'm going to take out a C plus D. This first term had 3 of them. We took 1 of them, so that leaves 2 of them. And then on the second term, we took the C plus D, and so all that's left is minus 4CD. Okay, it's maybe hard to know whether we should keep going, except I know if I FOIL this, I'm going to get a CD term. So I'm going to FOIL this out and combine and see what happens. Now it helps that I already know what I get when I FOIL that, so I'm not going to come out to the side and write it all out. I know it's going to be C squared plus 2CD plus D squared. All right, everyone knows that there's a CD term in there. It's not just C squared plus D squared. You can't distribute the square. Well, now I've got a CD term and a CD term. So that would be C squared minus 2CD plus D squared. 46 and 47 are probably the most annoying ones on the page, just because they keep going and going and going. In fact, I can now factor that. Let's see, it'd have to be C and C, and D, and if they're both minus, then there we go. And you can see how it's pretty similar to 46. Noah?
Do you have to put C minus D times C minus D, or can you just put C minus D squared?
Sure. Anytime you recognize that there's 2 factors and you want to write it as squared, that's okay. Yeah. By the way, I posted the answers. I don't think they were posted until 30 minutes ago. And sometimes I posted both, like I wrote both, and sometimes I only wrote one. but either way is okay. Either one of those is fine. Sometimes people see it right away as a squared term. Other times they don't see it right away, and then like, well, I don't really want to write it again. Either way. Oh?
36.
Yeah. Noah, were you going to ask about one?
No.
Okay. Oh, 36. Good. Because we haven't done a cube one yet. So hopefully I recognize that this is a sum of cubes. So this is a SOAP problem. Let's see. SOAP tells me the signs. Same, opposite, always positive. So SOAP is great, but it doesn't tell me what goes in the spots. So the first parentheses is usually the simpler one. So, Jacob, what's going to be in this spot right here? Wait, just this spot. Yep. Intercepted you. I'm sure you're going to be right, but I wanted to hear from Benji as well. So, Benji, what would go in this spot? What would I cube to get to 27n cubed? N's part of the answer.
3n.
So 3n. So you get the first parentheses like as soon as you recognize that both of these are cubes. When you recognize both of them are cubes, you can probably get the cube root of each of them. All right, the second one is square the first, multiply the two together, square the second. So, in that order, Carter, what's going to go in the first spot here?
M squared.
M squared. Square the first one. Abigail, what's going to go in the second spot? 3mn. Just multiply the two together. And we're not worried about signs because SOAP took care of the signs for us. 3mn. Didn't leave much room there. Keegan, how about in the last spot?
9n squared.
Yes. Do you know what I was worried? Not about Keegan, but someone of lesser math ability than Keegan. What some student might put there instead of 9n squared? You know, the common mistake when they go to square 3n. They forget to square the 3. Like everyone squares the n, but sometimes people forget to square the 3. Not Keegan though, he knew better. The square of 3n is 9n squared. And then the second term, like you could think about it or play with it, but the second term of a sum or difference of cubes never factors. So you can look at it and try to mess with it, but it will never work. So you don't have to worry about the second term of a cubic. You're just done. Good questions. Definitely hit everything I wanted to hit. Anything else? Karis? 48. Yes. 48. Let's see. Did you have a thought or an attempt on 48? What'd you try?
Try to, I don't know. I couldn't figure out what to factor.
Okay. So I'm definitely, the only thing that there's an option to do is factor something out. Because it's only two terms. They're definitely not cubes. They're definitely not squareds. Well, 4b could be squared, but 3 is not, and 5 is not. It's not minus anyway. So my only hope is to factor something out of there. So they both have some a's. How many a's can I factor out? I guess that's the question. There's 4b of them in this one, and there's 3b of them in that one. So I can take 3b a's out. Now I've got to figure out what goes in that blank. If I remember right, I almost messed this one up on the key. This is the one. Yep, almost messed it up. So a to what power? B. Oh, you guys are better than I was. I put a 1 there the first time. Because I was thinking 3 plus 1 is 4. Like, well, yes, 3 plus 1 is 4, but 3b plus b would get me to 4b. How about the second term? Yeah, just a 5. We took a to the 3b. So that's all you can do on 48. Which, I don't know, it feels weird. This worksheet sort of jumps around in terms of difficulty level. 47 took 6 or 7 steps. 48 took 1 step. Go. 37. Thank you. Do you recognize, like, big picture what's going on in 37? Especially given the section of problems it's in. There's cube things going on here. So both of those are perfect cubes. Now, the first one's a little bit weird, maybe. Not too weird for Madeline, though. What would we cube to get to k cubed over 27?
27.
So what times itself 3 times? What?
Oh, 3.
What would we cube to get to k cubed over 27? It need to be a factor. 1/3, so 3 in the bottom, and a k in the top. So that one, though, that was a weird one. Like, you recognize that they're cubes, but the fraction kind of throws us off. Same sign, same opposite, always positive. Grace, you got the easier one, I think. What would we cube to get to 8? 2. So there's our cube roots, but that's not all of the factoring. Same, opposite, always positive. So I got 3 more blanks to fill here. Jeremy, what's going to go in the first blank?
K over 3.
Close. Square all of k over 3.
Oh, K squared over 3 over 9.
There you go. K squared over 9. Noah, how about the second blank?
2K over 3.
Good. 2k over 3. And Micah, how about the third blank?
4.
4. Square the last one. And that looks kind of weird, but we know we don't do anything else with it, so okay, we're okay with a weird answer. All right, lots of good stuff there. Let's